Hello students, welcome to Arjun My classes. Today we solve this LPP by graphical method, and in the previous class we gone through the how to formulate the LPP, and today we'll go for this how to identify the optimal solution for the given problem. So here to identify this optimal solution, we are having two methods. One is we can verify or we can obtain the this optimal solution by graphical method, and other method is by simplex method, right? So but whenever we have two variables, then we can use this graphical method. Whenever we have more than two variables, then we can proceed for this simplex method. And simplex method is having advantage that we can utilize that simplex method for two variables, and we can use that for the more than two variables also. But today what we'll do, we'll go through the LPP by graphical method. Okay, so coming to the problem. So here we have one problem on maximization, and he's asking solve the given LPP by graphical method, right? So here is mentioning that graphical method, and already I told to solve this graphical problems we should have only two decision variables. If we have more than two decision variables, it is not possible to solve by this graphical method. Okay, that time what we have to do, we have to go for the other method like simplex method. Okay, coming to the problem, the maximize z equal to 12x1 plus 16x2 subjected to the constraints 10x1 plus 20x2 is less than or equal to 120, and 8x1 plus 8x2 less than or equal to 80, x1 comma x2 greater than or equal to 0. So here he given all the three conditions for the LPP problem, like objective function he given constraint equation, and he given the non-negativity conditions. Okay, so after this what we have to do is, so here we have a standard process, standard step is there for this. We'll proceed for that. Like step one, it is we have to convert, we have to convert, we have to convert this inequality equations into inequality equations into equal equations. So we have to convert this inequality equation. These are all the constraints we are seeing. So these are in inequality, means less than equal to, greater than equal to, they given now. So we have to replace this less than equal to or greater than equal to by equal to symbol. So then what we'll do, we'll change that one. 10x1 plus 20x2 is equal to 120, and second one is 8x1 plus 8x2 is equal to 80. So then we done this one. So then we have a process. We want to do the problem on a graphical method. We need coordinates. So how to get these coordinates? So here we have two variables, like x1 is 1 and x2 is 1. So we have to prepare a coordinates for these two. So then what I will do, I will take the first equation here, 10x1 plus 20x2 12x 10x1 plus 20x2 is equal to 120. So to get this x1 and x2 values, what I will do, I will put once x1 as 0, put x1 equal to 0, then x2 value will get as 6. So when x2 is equal to 0, when we put this x2 as a 0, then x1 value is going to become 12. So like this we have to proceed for the another equation, 8x1 plus 8x2 is equal to 80. So put x1 equal to 0, then x2 value is going to become 10. Put x2 equal to 0, then x1 value is going to become 10. So what we'll do next, once it is done, so we'll for our understanding purpose, we'll make in a table, in a simple table I will represent them. For the equation 1, table is like this. When x1 is 0, x1 and x2, when x1 is 0, x2 value was what, 6. When x2 is 0, x1 value was 12 for the first equation. Second equation, so you can see here, so again we have to create a table. X1 and x2. When x1 is 0, x2 value was 10. When x2 equal to 0, the x1 value was 10. So then from this coordinates we have to create a graph. Graph plotting. So what we'll do, so we'll plot a graph with respect to this x1 and x2. So what I will do now, I will plot a graph for this one. Okay, so along x-axis I will consider it as a x1, and along y-axis I will consider it as a x2. So then what I will do, so I will write the coordinates here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12. Similarly for this one also I will write here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right, we written all these three coordinates here, all the both the coordinates we written here. Next work is what we have to plot a graph by using this given data. So what I will do, so first one we'll see here. So for the first equation, so when x1 was 0, x2 value was 6. When x1 was 0, x2 value was 6. When x2 was 0, what was the x1 value? Here x1 value was 12. So just we have to join these two. Right, we join this. Next work is we have to go for the second one here. When x1 is 0, for second equation, when x1 is 0, x2 value was 10. When x1 was 0, x2 value was 10. Similarly, when x2 was 0, when x2 was 0, x1 value is 10. So we have to join these two. Right? So now coming to the equations here, in a problem it is given. So whenever this less than or equal to symbol will come in the maximization problem, so then the feasible region will be located below the line. It will be located below the line. Right? So now here we have both are in a less than equal to condition. So for the first line, this is for my first constraint. For first constraint, the feasible region is located below this line, and second constraint is also located below this line. So if I can't take this region for this second one only, but for once we take this one as a feasible region, for this it will become above the line. So we have to satisfy both the lines here. So for both the lines it should be below the line. So I will consider this is going to become the below the line region. So this I will call it as a feasible region. This I will call it as a feasible region. Okay, we identified the feasible region now. Next one, once we identified the feasible region, so we have to identify the optimal solution at which point we are getting the maximum value or maximum profit. So we have to identify here. To identify this, we have to represent four coordinates which are coming under this feasible region. So here we are having a boundary of this one. It is connected with the four corners. So this coordinate, this corner I will call it as a, and second corner I will call it as a B, and third corner I will call it as a C, and fourth one I will call it as a D. So I will take down the coordinates of all the four corners. So A coordinates is A corner is having coordinates of 0, 0, and B1 is having the coordinates 10, 0, and C is having 8, 2, and D is having 6, not 6, 0, 6. Right? So what we do now? So we'll substitute these coordinates into the objective function. What is our objective function here? The objective function equation is 12x1 plus 16x2. It is our objective function. So I will substitute these all the values here. So ZA equal to 12 into x1, it is going to become 0. 16 into x2 is going to become 6. So then it is total is ZA value is 0. So ZB having a coordinates x1 as 10 and x2 as 0. So 12 into 10, it is going to become 120, and 0 into 16, it is going to become 0. So ZC equal to 12 into 8 plus 2 into 16 into 2. So then it is going to become 12 8 is 96 plus 32. It is going to become 128. Okay, so last one ZD equal to optimal solution at the corner D is 12x1 is 0, 12 into x1 is 0, is going to become 0, 0 plus 16 into 6, it is going to become 96. So then total value is 96. So now we got all the, for all the corners we got the optimal solution. So next work is what? So we have to identify the the maximum result, maximum value. So we have to identify the maximum value because the problem is subjected to what? Maximization. So in this problem you can see here for all these corners we got a values. In this which is maximum, there our maximization, maximum profit is possible. So what I will do is this is going to become my optimal solution. Z equal to 128 is going to become my optimal solution, and coordinates for this one, decision variables are going to become x1 comma x2, they are going to become 8 comma 2, means x1 equal to 8 and x2 equal to 2. This is the problem. Thank you.